Hi, welcome back to Moose in Chemistry. This is electron configuration of Ytterbium, YB lesson. I hope I said that one right. Okay, well, Ytterbium happens to be element number 70. So we're going to have 70 for our atomic number. And the atomic mass number is going to be 173. Okay, so we have 70 protons. Since it's electrically neutral, it would be 70 electrons. Now, what about our neutron count? Remember that is AMU minus the number of protons equals our number of neutrons, right? So you got 173 minus 70, and that's going to be 103. Okie dokie. Pretty darn snarly, eh? Pretty easy. Easy as can be. Okay. Now, let's get back to this. So now we're going to be doing the electron configuration, the orbital notation, the noble gas notation, and the quantum numbers for the element Ytterbium. Okay. Remember that the s suborbits can only hold 2 electrons. The p suborbits can hold 6 electrons. The d suborbit can hold 10 electrons. And the f suborbit can hold 14 electrons. We're going to use the off-ball principle, which states fill the lower shells first before you fill the upper shells, and we're going to use the diagonal rule. So let's put an X right here on the top of the diagonal rule here. And we're going to start down the slides. We're going to slide down these orange arrows until we run out of electrons, right? Okay, sounds pretty easy. So we go 1s2. By the way, we're doing 70 electrons. 2s2. Come back up here, 2p6. 3s2. Wow, this is so cool. 3p6. See how easy this is? It is so easy. 4s2. Wow. 3d10. A lot of sliding. 4p6. 5s2. 4d10. 5p6, 6s2, and finally 4f14. Snarls! See how easy that was? That's so cool. So now, our orbital notation is our next notation. Now with orbital notation, we're going to use something called Hund's rule. And Hund's rule basically says that you have to put an up arrow in the suborbit of every one of those suborbits of that particular energy level before you put the down arrow, right? Okay, so let's demonstrate it. Okay, up arrow, down arrow, 1s, only holds 2 electrons, remember? That's done. 2s, up and down. Now look at this, 2px, 2py, 2pz, so you go 1, 2, 3. You put an up arrow at every suborbit according to Hund's, and you do the down arrow. See how easy that is? Pretty easy, guys. Alright, so now we're just going to keep on going down through this and just watch how I do it, because this is the technique you should probably use. See how easy that is? Yep. Pretty darn snarly is all I got to say. Okay, so far so good. Alright. And we're just going to keep on going through here. And 5s. Okay. See how easy that was? Tell you, man, this is something you can have fun with on the weekend with your friends. Yes, they'll truly be your friends if they work with you on this. Chemistry is kind of an awesome subject to have to take, and it's awesome because you get to form so many friendships. And you get to test your friendships, because your true friends will stand by you and work with you on these amazing problems. Alright, so now there's 7 ups and now we do 7 downs. Pretty amazing. That's all I got to say. Alright, now our noble gas notation. The purpose of doing noble gas notation is to kind of like take a whole bunch of information like an electron configuration and kind of shorten it down. It makes it a lot easier to see and to read. So the nearest noble gas, can't do the ones after ytterbium, you have to do the one before, would be xenon. So it'd be Xe. And we know that xenon's electron configuration actually ends in 5p6, right? So we come all the way out here and we're going to box this. Just like that. And that is Xe's configuration. So all that leaves is this stuff right here. And you have to put in numerical order. So it'd be 4, F, 14, 6s2. Now some people put the 6s2 first before F14. It's been kind of like, I don't know, half the chemistry world wants to do it that way, the other half wants to do it the way I just did it. The actual more correct way is to put the 4F14 first and the 6s2. I guess it would depend on who your instructor is, but whatever they tell you to do, just do it. You know, as far as the ordering of the noble gas notation. All right, now it appears that ytterbium is in energy level 6 or period 6, but it's not, because think about this. It's in the F block, right? So it's N minus 2. So you would go 6 minus 2 would give you 4. So your N value is 4. Your L value is in the F block, right? So it's going to be 3. That's the angular momentum. The magnetic number is going to be the last one, so it's going to be the last one in the block. And that last arrow right here is going down. So it's going to be 1/2 negative. This was pretty easy and pretty darn snarly. You guys be snarly also. And we'll see you back here at Mucine Chemistry.